light fields are great, light fields are awesome. But there are some problems. Kind of 3 off the top of my head. Data, data, and data. That 4D embedding, of course, is using a lot of pixels to do that, right? So if you want high resolution, you have to start with a super, super high resolution sensor. There's also a couple other issues. Obviously, you have to have pretty good optics if you want to keep those rays separate, and you don't want to throw any rays out. You got to keep the ray bundles fairly tight. And finally, getting locked out of the grade. If you thought it was bad that like you didn't know what color your images were going to come out the other side, and maybe they're going to crop it on you, imagine that they start changing the F number you shot at and doing all sorts of crazy stuff to your image. So this is sort of the dystopian future of amazing light field video. Just wanted to set you up properly, John. So here's a quick plug for us. We're VISBY. I found a brilliant physicist of my own, and we are working on some amazing light field technology. Maybe in a year we'll have something to show. But in the meantime, we're hiring. So message me on LinkedIn if you like, and I'll talk to you after the show.
This scene was actually the 3rd place winner in the 3rd month. But what's striking to me about this is that it's so realistic. It's actually a real place, based on a real place in Japan. It's a temple, and it looks basically like a photo, except we can render it from any angle we want. We can actually, pull back and, even go very high up. And so if you think about really how this was constructed, what's great about it is you really want to have something that loads up as a scene file in a 3D render and just looks like the real world. And in this case, we were actually taught something by our users. And this particular artist went out there and he basically took his camera and he took a lot of photos. And using very simple off-the-shelf photogrammetry tools, he was able to create the scene that you saw and really make it work and pop out in 3D. And I think that is the future. So without any of our help, with a very tight timeline, this was done in basically over a couple of weekends, you can see amazing scenes that are being created, and we can render them today as stereo cube maps, tomorrow as volumetric holographic streams. But ultimately, you want to be able to sort of create a metaverse where you can compose these things and mix them together. The market itself, I mean, from just the perspective of how big it is I think this may even be conservative. I think that it's going to be very clear very soon that it's not just about VR and AR. There's just something bigger around immersive and volumetric media. It's really something that you can always downgrade to a 2D display, just like color and HD can go down to black and white standard definition. But if you start at the highest end when you're creating content and you're creating experiences, I think that means that the entire ecosystem of content creation is going to be affected very early on, and that's really important for people that are creating content and creating tools around it like us. And it's exciting. I think this is going to be a huge space, and we're just at the very, very early stages of that. And light fields and holographic content are definitely a big part of the future. So we're excited to help and do our part. Thank you guys very much.
Talk about how the camera actually operates. And Ryan did probably one of the best jobs ever explaining how light field works and how the camera technologies work. So I'm going to take a very high-level overview and give you a bit of an idea of how Lytro Cinema is physically capturing those rays of light. So we start off here, as soon as it switches, with the micro lens array. And this is the core underlying technology that allows us to take in all of the rays of light from a main lens aperture and then have that focus in at the micro lens itself and then split those rays into the angular components that provide you with the 4D function of the light field. So in the sample that you see here, that actually was a micro lens array that you would have seen in our 1st generation cameras, so the ones that looked like a little butter stick. And that has over 100,000 lenses within that tiny little piece of glass. And that is actually produced at the wafer level. And you have seen now we have multiple generations finally leading into the Lytro Cinema technology, where we have gone a bit crazy and made something that is very big and really awesome. But again, before I get ahead of myself. So the general concept behind the micro lens array is the premise of taking all of the perspectives of light, all of those rays from a light field array capture apparatus, like the one you see here on the left, which actually you saw in the earlier presentation, and then by using the micro lens technology, being able to compress that into a single lens and a single sensor. When I say a lens, I'm referring to specifically the main lens that goes into the actual camera itself. Obviously, there are hundreds of thousands, if not millions, of lenses that exist right in front of the digital imaging plane. So the way that we actually are capturing and receiving those rays of light is you have your one main lens, and obviously this is a simplified version just for explanation. But you have all of the rays, and if you imagine here everything is collimated, they will all converge at the actual lens itself in terms of those micro lenses that you see in front of the digital imaging plane. And then once the light rays actually physically converge, you're seeing the light being broken apart because at focus, you now are adding in the actual theta and phi angular dimensions to that holographic image that you're getting from a light field camera. So here you're seeing just a quick, very low resolution example. This would be considered a 6x6 pixel bucket behind each of those microlenses, but that's a really important concept because when you want to tie back from the idea of the big light field array systems back into a microlens technology, that 6x6 is effectively giving you discrete views from a 6x6 array of cameras. So if you have 10x10, that gives you 100 cameras. If you have 20x20, and so on. So what does this all mean? What can you do with this? When you capture with a light field capture system, you are capturing all of those rays of light, and this is actual content coming off of the Lytra Cinema system, but you're not only capturing the intensity and the color of the information, you're also capturing the directionality, meaning where does it exist in space. You can calculate from that the normals of everything. If you want to produce any type of relighting for your scene, you can capture any of the depth information. You can then do things like a depth screen, as some of you may have seen that we published a lot of that information, where you can extract the foreground and the background or any object within the scene just by having the light field itself.
Yes, question.
Yes, Pat Griffiths. So fascinating presentation, and I agree with Pete. Here's some more history making at this conference. But 755 megapixels per frame, what about the bit depth and actual terabytes per frame?
Fortunately, we're not at terabytes per frame, so we can say that. So you can look at it as being 10 or 12 bit. In the future, it's going to go beyond that. One of the things that's really important is the idea of decoupling the idea of your bit depth and your dynamic range. That with light field, those are in fact decoupled because you have the ability to resample on basically theta and phi in different ways that you can't do with a traditional 2D image. So you're looking at the ability to have a raw image that just, you can round the numbers at a 10-bit of on the 750 megabyte per frame range. And then with the compression, once you do all of the image processing, you do everything else that is required for the actual content itself, then you can do kind of a 10-to-1 compression ratio based on the full color image to get you in that kind of ballpark with the EXRs. And then obviously everything depends on frame rate. So the solution to that is fundamentally having the ability to build an architecture that you can offload the processing and the data storage requirement from the end user or the studio or the artist. And that's where we're going to be showing off a bit of the advances that we have on the cloud ecosystem that is really core to being able to work with this technology freely and not really have to be inhibited by local processing.